What if every choice you've ever made, what to eat for breakfast, who to fall in love with, even the thoughts running through your head right now, wasn't really a choice at all? What if, from the moment the universe began, every event was locked into place like dominoes falling in an unbreakable chain? This isn't science fiction. It's the spine-tingling idea at the core of determinism, a theory that suggests the universe operates like an intricate, unyielding machine where every outcome is inevitable. And if that's true, it means the story of your life was written into the fabric of reality billions of years before you were born. But here's the twist: science and philosophy have been locked in a centuries-long battle over whether this is really how our universe works. Think about the last time you hesitated between two decisions. That feeling of weighing options, of believing you had control. What if it was just an illusion? The debate over determinism forces us to confront questions that cut to the very heart of existence. If the laws of physics dictate everything, from the motion of planets to the firing of neurons in your brain, where does that leave free will? And what happens when we bring quantum mechanics into the mix, with its inherent randomness that seems to defy the idea of a predictable universe? This isn't just abstract theorizing. The answer could reshape how we understand everything from human responsibility to the nature of time itself. From Isaac Newton's vision of a clockwork cosmos ticking along with perfect precision, to the bizarre uncertainties of quantum particles that appear to dance to no discernible rhythm, the story of determinism is a roller coaster of breakthroughs and paradoxes. And here's why it matters now more than ever. With advancements in fields like artificial intelligence and neuroscience, we're edging closer to answers that could redefine what it means to be human. So buckle up. Over the course of this journey, we'll unravel the threads of this monumental debate, exploring how philosophers, physicists, and even neuroscientists have grappled with the same haunting question. Are we the authors of our destinies, or is the universe pulling the strings all along? The truth might just leave you questioning everything you thought you knew. To understand determinism, picture the universe as a vast, intricate tapestry where every thread is woven by the laws of physics. Each event, whether the birth of a star, the flutter of a butterfly's wings, or the firing of a single neuron in your brain, is stitched into place by the conditions that came before it. Nothing is left to chance. This idea was crystallized by the French mathematician Pierre-Simon Laplace in the early 19th century. He famously proposed that if some all-knowing intellect, later called Laplace's demon, could grasp the precise position and momentum of every particle in the universe at a single moment, it could calculate the entire past and future with absolute certainty. No uncertainty, no surprises, just an unbroken chain of cause and effect stretching from the Big Bang to the end of time. But here's where things get slippery. If determinism holds true, then every decision you've ever made, from choosing a career to picking a coffee mug this morning, wasn't really a choice. It was simply the unavoidable outcome of particles obeying physical laws set in motion billions of years ago. Your sense of free will, just a convincing illusion, like a character in a movie believing they're making spontaneous choices when, in reality, every line and action was scripted long before. Philosophers call this hard determinism, the unflinching view that all events, including human actions, are preordained by prior causes. Yet the universe doesn't always play by such rigid rules. Enter quantum mechanics, the strange and unpredictable realm of subatomic particles. At this tiny scale, particles don't follow neat, deterministic paths. Instead, they behave probabilistically. Electrons pop in and out of existence, particles tunnel through barriers, and measurements can't be perfectly predicted, only assigned odds. This inherent randomness, championed by thinkers like Werner Heisenberg, throws a wrench into Laplace's clockwork universe. If the building blocks of reality are fundamentally uncertain, how can the future be set in stone? This tension between determinism and quantum uncertainty fuels one of the most heated debates in science and philosophy. Some argue that quantum effects average out at larger scales, leaving our everyday world mostly predictable. Others propose that free will emerges from this microscopic chaos, like a symphony rising from the noise. But one thing's certain, the question isn't just academic. It shapes how we view justice, morality, and even our own identities. If our actions are predetermined, can we truly hold anyone responsible for their choices? Or are we all just passengers in a universe that's been on rails since the beginning of time? The answer might lie somewhere between the ticking gears of Newton's physics and the quantum dice roll, a mystery that continues to unravel with every scientific breakthrough. Laplace's demon sounds like something straight out of mythology, a being with godlike knowledge, capable of seeing every atom, every ripple of energy, every hidden force weaving the fabric of reality. But Pierre-Simon Laplace wasn't spinning a fable. He was making a serious philosophical point about the nature of the universe. Imagine this creature, this demon, with perfect knowledge of every particle's position and momentum at any given instant. With that information, and with the unbreakable laws of classical physics as its guide, it could rewind time to witness the birth of the cosmos or fast forward to watch its final moments. Nothing would be hidden, no event would be left to chance. The universe, in this view, is a colossal domino setup where the first push determines every fall that follows. This idea didn't come out of nowhere. It was the natural extension of Isaac Newton's laws, which described the motion of planets and apples with such precision that scientists began to wonder, if we could measure everything, could we predict everything? For centuries, this clockwork universe seemed not just plausible but inevitable. The sun rose and set on schedule. Comets returned like cosmic metronomes. Even human behavior, some argued, might just be the result of physical processes obeying nature's laws. But then came the 20th century, and with it, the quantum revolution. Suddenly, the demon's perfect vision started looking a little blurry. At the smallest scales, particles refused to play by Newton's rules. Electrons didn't orbit atoms like tidy little planets. They existed in clouds of probability, popping in and out of places unpredictably. Werner Heisenberg's uncertainty principle declared it impossible to know both a particle's position and momentum with perfect accuracy. The harder you tried to pin one down, the more the other slipped away. It was as if the universe itself was telling Laplace's demon, "You can't see everything, no matter how hard you try." This quantum weirdness didn't just challenge determinism, it shattered the very foundations of predictability. If the building blocks of reality operate on chance, how could the future ever be set in stone? Some scientists, like Albert Einstein, resisted this idea, famously declaring, "God does not play dice." Others embraced the uncertainty, arguing that probability is woven into the fabric of existence. So where does this leave Laplace's demon, trapped in a paradox? On one hand, the macroscopic world, planets, people, coffee cups seems to follow predictable cause and effect rules. On the other, the microscopic realm is a storm of randomness. Maybe the demon could still predict the broad strokes, the rise and fall of civilizations, the orbits of galaxies, but the finer details, the quantum quirks, would always be just out of reach. And if that's true, then the universe isn't a pre-written script. It's more like an improv performance with room for surprise, spontaneity, and perhaps even free will. The debate isn't just about physics. It's about what kind of universe we live in, one of rigid fate or open possibility. And as we peer deeper into the quantum world, the answer might not be a simple either-or. It could be something stranger, something that forces us to rethink the very meaning of determinism itself. Isaac Newton gave us a universe that ran like a perfect, unerring timepiece. His laws of motion transformed the cosmos into a stage where every action had an equal and opposite reaction, where planets traced elliptical orbits as if guided by an invisible hand. The math was elegant, the predictions stunningly accurate, comets returning right on schedule, tides ebbing and flowing like clockwork. For generations, this vision of a deterministic universe seemed unshakable. If you knew the starting conditions, the position, velocity, and forces acting on every object, you could calculate their future states with unerring precision. The universe, in Newton's framework, was a colossal machine, its gears turning with mathematical inevitability. But machines have limits. Even the finest pocket watch, if jostled too hard, begins to stutter. Scientists eventually realized that Newton's clockwork universe had blind spots. Take something as simple as a double pendulum, a pendulum attached to another pendulum. Its motion starts predictably, but give it a slight nudge and chaos erupts. Tiny differences in initial conditions spiral into wildly divergent paths, defying long-term prediction. This phenomenon, later formalized as chaos theory, revealed that some systems are inherently sensitive, their futures impossible to pin down no matter how precise your measurements. The universe, it seemed, had a rebellious streak. Then came quantum mechanics, and the cracks in Newton's edifice became chasms. At the subatomic level, particles refused to follow neat trajectories. An electron doesn't orbit an atom like a planet around the sun. It exists as a probability cloud, a haze of potential locations. Measure its position, and its momentum becomes fuzzy. The very act of observation changes the system. Werner Heisenberg's uncertainty principle wasn't just a technical hurdle. It was a fundamental declaration that the universe resists perfect knowledge. Einstein fought this idea, insisting that God does not play dice, but experiment after experiment confirmed the quantum world's inherent randomness. So was Newton wrong? Not exactly. His laws still govern the motion of baseballs, rockets, and galaxies with breathtaking accuracy. But they're a special case, a simplified rulebook that works astonishingly well under everyday conditions. Step into the realm of the very small or the very complex, and the tidy determinism of classical physics gives way to probability and unpredictability. The clockwork universe wasn't a lie. It was just a first draft, a glimpse of a deeper, stranger reality where certainty dissolves into waves of possibility. And that leaves us with a haunting question. If the foundations of reality are uncertain, what does that mean for the choices we think we're making? Are we still just cogs in a machine, or is there room for something more? If Newton's clockwork universe ran like a perfect machine, chaos theory is the wrench that jams its gears. Picture this: a butterfly flaps its wings in Brazil, and weeks later, a tornado tears through Texas. This isn't poetic exaggeration, it's the essence of the butterfly effect, the star player in chaos theory. At its core, chaos theory reveals a startling truth. Even in a universe governed by strict deterministic laws, predictability has its limits. Tiny, imperceptible differences in starting conditions can snowball into wildly different outcomes, turning what should be a straightforward cause and effect chain into a tangled web of uncertainty. Take weather forecasting. Meteorologists use supercomputers crunching mountains of data, yet beyond a week or two, their predictions become little better than guesses. Why? Because the atmosphere is a chaotic system. A rounding error in one measurement, a temperature reading off by a fraction of a degree, a wind gust unaccounted for can cascade into completely divergent weather patterns. The same principle applies to planetary orbits. Our solar system might seem like the ultimate example of Newton's predictable clockwork, but over millions of years, gravitational interactions between planets introduce tiny perturbations. These minute shifts can lead to orbital chaos, making it impossible to pin down the exact positions of planets far into the future. But here's the million-dollar question. Is chaos true randomness, or is it just determinism wearing a mask? On the surface, chaotic systems appear random, unpredictable, erratic. Yet underneath, they're still governed by rigid mathematical rules. There's no dice rolling, no quantum-style probability. Every outcome is theoretically traceable back to its initial conditions. The problem isn't the laws of physics breaking down, it's our inability to measure with infinite precision. Miss one minuscule detail, and the whole system veers off course. This blurry line between determinism and unpredictability has philosophers and scientists locked in debate. Some argue chaos theory doesn't undermine determinism, it just highlights our practical limits. The universe might still be a domino chain, but we'll never have a God's eye view of every tile. Others see chaos as a gateway to something deeper, a hint that even deterministic systems can produce behavior so complex it's indistinguishable from true randomness. And then there's human behavior. Our brains, with their billions of neurons firing in intricate networks, might be the ultimate chaotic systems. Every thought, every decision could be hypersensitive to initial conditions, a stray memory, a fleeting sensation, making long-term prediction of our actions a fool's errand. Does that mean free will emerges from this chaos? Or are we just unwitting participants in a deterministic system so complex it feels like choice? The answer might lie somewhere in the stormy intersection of physics, philosophy, and the unpredictable flutter of a butterfly's wings. Quantum mechanics doesn't just challenge determinism, it flips the script entirely. Imagine rolling a die, but instead of landing on a number, it hovers in midair, existing as a blur of all possible outcomes until you reach out and grab it. That's the bizarre reality of the quantum world. Particles like electrons don't have definite positions or momentums until they're observed. They exist in a haze of probabilities, described by wave functions that collapse into certainty only when measured. This isn't a limitation of our tools, it's a fundamental feature of the universe. Einstein resisted this idea, convinced that God does not play dice, but decades of experiments from the double-slit experiment to quantum entanglement have proven otherwise. The universe at its core seems to thrive on uncertainty, but here's where it gets even stranger. Quantum randomness isn't just a quirk of tiny particles. Its effects can scale up. Consider radioactive decay. There's no way to predict exactly when a single atom will decay. It's a pure game of chance. Yet, when you pile enough atoms together, their behavior becomes statistically predictable. This duality, randomness at the micro level, predictability at the macro, creates a paradox. If quantum events can influence larger systems, does that mean the universe has built-in wiggle room? Could a single quantum fluctuation alter the trajectory of a molecule, then a cell, then a thought? Some scientists, like those exploring quantum biology, suspect these effects might even play a role in processes like photosynthesis or bird migration, blurring the line between the quantum and the everyday. Then there's the multiverse theory, a radical twist on quantum mechanics. Every time a particle faces multiple possible states, the universe might split into branches, each realizing a different outcome. In this view, the dice aren't just rolled, they spawn entirely new realities. It's a staggering idea. Every choice, every chance event could spawn alternate timelines where different versions of you live out every possible permutation. If true, determinism isn't just broken, it's replaced by an infinite tapestry of possibilities. Yet not everyone is ready to abandon determinism. Hidden variable theories propose that quantum particles only seem random because we're missing key information. Perhaps there's a deeper layer of reality, unseen forces guiding particles in ways we can't yet detect. This was Einstein's hope, a universe that's ultimately orderly, even if its mechanics remain hidden. But so far, experiments have ruled out many of these hidden variable models, leaving genuine randomness as the leading explanation. The implications ripple far beyond physics labs. If quantum mechanics injects true unpredictability into the universe, it opens a door, however narrow, for free will. Not the mythical, unconstrained kind, but a version where our choices are shaped by a mix of deterministic laws and quantum chance. It's a messy middle ground, but one that might just reconcile the clockwork cosmos of Newton with the chaotic creativity of human experience. The question isn't just whether the universe is deterministic. It's whether we're brave enough to live in one that isn't. Einstein and Bohr's intellectual duel wasn't just a scientific disagreement, it was a philosophical war over the soul of reality itself. On one side stood Einstein, the towering figure who had reshaped physics with relativity, clinging to his conviction that the universe was orderly and predictable at its core. He couldn't stomach the idea that God would leave things to chance, famously quipping, "I, at any rate, am convinced that he does not throw dice." To him, quantum mechanics randomness wasn't a fundamental truth but a placeholder, a sign that the theory was incomplete. Hidden variables, he insisted, must lurk beneath the surface, unknown factors that, once discovered, would restore the universe's deterministic heartbeat. Bohr, on the other hand, met uncertainty with open arms. To him, quantum mechanics wasn't broken. It was revealing a deeper truth about nature's irreducible unpredictability. He argued that particles don't possess definite properties until they're measured, and that the act of observation itself shapes reality. Think of it like trying to describe a dream before you've fully woken up. The harder you grasp for certainty, the more it slips away. Bohr's Copenhagen interpretation became the flag-bearer for this radical view, painting a universe where probability, not inevitability, was the foundation. The tension between these two visions wasn't just academic. It spilled into legendary late-night debates at conferences, with Einstein devising clever thought experiments to expose flaws in quantum theory, and Bohr countering with equally sharp rebuttals. At one point, Einstein proposed a scenario involving boxes and photons, hoping to prove quantum mechanics inconsistent. Bohr stayed up all night, wrestling with the problem, only to turn the tables by using Einstein's own theory of relativity to dismantle the challenge. These clashes weren't just personal, they were the birthing pains of a new understanding of reality. Then came John Bell, a physicist who transformed the debate from philosophy into something testable. His theorem, published in the 1960s, provided a way to distinguish between hidden variables and true quantum randomness. If Einstein was right, certain statistical correlations in particle behavior would hold. If Bohr was right, those correlations would break. Decades of painstaking experiments, most famously by Elaine Aspect and others, confirmed the violations Bell predicted. The universe, it seemed, really was as weird as quantum mechanics suggested. Yet the story doesn't end there. Even with Bell's theorem tilting the scales toward Bohr, the allure of determinism hasn't faded. Some researchers still chase pilot wave theories, where hidden variables guide particles in unseen ways. Others explore the many worlds interpretation, where every quantum possibility branches into a new reality, a strange kind of determinism where every outcome happens, just in different universes. What makes this debate so enduring isn't just the physics, it's the existential weight behind it. If Bohr was right, the universe is fundamentally unpredictable, a place where probability reigns and certainty is an illusion. If Einstein's ghost could whisper in our ears, he might remind us that science has overturned paradigms before, that today's randomness could be tomorrow's overlooked pattern. One thing's certain, the tension between these two giants still echoes in every lab where quantum particles defy expectations, and in every human mind that dares to ask whether the universe plays by rules we can ever fully know. Hidden variables might sound like a physicist's last-ditch effort to save determinism, and in a way they are. The idea is simple yet profound. What if quantum particles only appear random because we're missing a piece of the puzzle? Picture flipping a coin. To you, it's a 50-50 chance. But if you knew the exact force of the flip, the air resistance, the surface it lands on, you could predict heads or tails with certainty. Hidden variable theories suggest quantum mechanics works the same way. Underneath the apparent randomness, particles could carry hidden information, like invisible coordinates, that dictate their behavior. If we could uncover these variables, the quantum dice rolls would reveal themselves as perfectly predictable events, and the universe's clockwork heart would keep ticking. This wasn't just wishful thinking. For decades, physicists like David Bohm championed hidden variables as a way to reconcile quantum weirdness with determinism. Bohm's pilot wave theory, for example, proposed that particles are guided by a quantum potential, an unseen wave that steers them along definite paths, even when no one's looking. It's like a submarine following an invisible current. The path seems mysterious from the surface, but there's a hidden force calling the shots. For determinists, this was a lifeline. If true, it meant quantum mechanics wasn't fundamentally random, just incomplete. But then came John Bell's bombshell. In the 1960s, Bell devised a way to test whether local hidden variables, the kind that operate without spooky action at a distance, could explain quantum correlations. His theorem set strict limits on how particles could behave if determinism held. When scientists like Elaine Aspect ran the experiments, the results were clear. Quantum particles violated Bell's inequalities. They were more entangled, more synchronized than any local hidden variables could allow. It was a knockout punch for Einstein's dream of a fully deterministic local universe. That doesn't mean hidden variables are completely dead, though. Bohmian mechanics, for instance, survives by embracing non-locality, the idea that particles can influence each other instantly, no matter how far apart they are. It's a radical trade-off, preserve determinism, but at the cost of allowing faster-than-light connections. For some, that's a bridge too far. Critics argue non-local theories are cumbersome, adding layers of complexity without offering testable advantages over standard quantum mechanics. Others see them as elegant solutions to the measurement problem, carving out a deterministic path through the quantum fog. So where does that leave us? Hidden variables remain a fringe but stubbornly persistent idea, a testament to our longing for a universe that makes sense. They may not fit neatly into mainstream physics, but they force us to ask deeper questions. Is randomness truly fundamental, or just a placeholder for laws we haven't discovered yet? Could there be a deeper layer of reality where cause and effect still reign, even if we can't see it? The answer might lie beyond our current theories, or it might force us to accept that the universe, at its core, thrives on uncertainty. Either way, the search for hidden variables isn't just about saving determinism. It's about how far we're willing to go to find order in the chaos. If every thought and action is just the inevitable result of prior causes, a chain reaction stretching back to the Big Bang, then what happens to the idea of free will? This isn't just philosophical hair-splitting. It strikes at the core of how we see ourselves. Take a moment to think about the last time you deliberated between two options, weighing pros and cons before making a choice. That feeling of agency, of being in the driver's seat, might be the most vivid experience we have. But if determinism is true, that experience could be a mirage, a story our brains tell us to make sense of decisions that were already baked into the universe's code long before we arrived. Neuroscientist and philosopher Sam Harris pulls no punches on this point. He argues that our sense of free will is an illusion, a trick of the mind. Every decision you've ever made, from what to eat for lunch to who to marry, was the product of prior causes. Your genetics, your upbringing, even the random firing of neurons you have no conscious control over. In Harris's view, you're not the author of your choices. You're more like a reader flipping through a book written by forces beyond your awareness. And if that's the case, the very idea of praise or blame starts to crumble. How can we hold someone morally responsible for actions they were destined to take? But not everyone is ready to toss free will on the scrap heap. Philosopher Daniel Dennett offers a middle path called compatibilism. The idea that free will and determinism can coexist as long as we rethink what free will really means. For Dennett, it's not about breaking the chain of cause and effect. It's about recognizing that some causes originate from within us. When you deliberate, when you act based on your desires and beliefs, that's free will in action, even if those desires and beliefs were shaped by earlier events. Think of it like a river flowing downhill. The water follows the path of gravity, yes, but within those constraints, it still twists and turns, carving its own unique course. The stakes here couldn't be higher. If Harris is right, our entire justice system, built on the notion of personal responsibility, rests on shaky ground. Punishment starts to look less about fairness and more about conditioning, like training a dog not to chew shoes. But if Dennett's compatibilism holds, we can still meaningfully talk about choice, even in a deterministic universe. It just means our freedom isn't the magical, unconstrained kind we might imagine. It's messier, more nuanced, the freedom of a jazz musician improvising within the rules of harmony. This debate isn't just academic, it shapes how we live. If you believe your choices are illusions, does that drain life of its meaning? Or does it liberate you from the weight of regret, knowing every misstep was inevitable? On the flip side, if compatibilism is true, does that give us permission to hold onto responsibility not as a cosmic truth, but as a practical tool for building a society? The answers aren't just hidden in philosophy textbooks. They're etched into every decision we make, every judgment we pass, and every moment we spend wrestling with the haunting question: are we truly free, or is freedom just another story we tell ourselves to make sense of the cosmic script? Imagine sitting in a lab, wires snaking from your scalp to an EEG machine, while a researcher asks you to press a button anytime you feel the urge. You wait, focusing on the moment of decision, then deliberately press it. But here's the unsettling twist. The machine detects a spike in brain activity nearly half a second before you're even aware of making the choice. This isn't science fiction. It's the famous Libet experiment from the 1980s, a study that sent shockwaves through neuroscience and philosophy. If your brain decides before you do, what does that say about free will? Are we just spectators to choices already made by the machinery of our neurons? Dig deeper into the brain, and the evidence gets even more provocative. Modern fMRI studies show that patterns of neural activity can predict simple decisions like moving a hand or choosing between images several seconds before subjects report feeling any intention. It's as if the brain is a committee voting behind closed doors, while consciousness only gets the memo after the fact. Some researchers argue this paints a stark picture. Our sense of agency might be a post hoc narrative, a story the brain constructs to explain actions already set in motion. Philosopher Patricia Churchland sums it up bluntly: the brain decides and then the mind rationalizes. But before we resign ourselves to being meat robots, there's a counterargument brewing. What if consciousness isn't just a passive observer but an emergent phenomenon, a kind of executive summary the brain generates to coordinate complex decisions? Think of a symphony orchestra. Individual neurons might play their parts automatically, but the conscious mind could be the conductor, shaping the overall performance without micromanaging every note. This view, championed by neuroscientists like Antonio Damasio, suggests that while our choices may emerge from deterministic processes, consciousness still plays a crucial role in weaving those processes into coherent actions. Then there's the wild card of neuroplasticity. Unlike rigid machines, our brains constantly rewire themselves in response to experiences. Every thought, habit, or learned skill physically alters neural pathways. In this light, the brain isn't just following a pre-written script, it's a dynamic system where past choices influence future ones, creating feedback loops that defy simple determinism. A recovering addict resisting temptation isn't just a puppet of physics. They're leveraging consciously reinforced pathways to override automatic impulses. The debate gets thornier when we consider creativity. If the mind were purely deterministic, how do we explain sudden flashes of insight, the aha moments where solutions appear out of nowhere? Mathematician Henri Poincaré described his breakthroughs as arriving fully formed during leisurely strolls, as if his subconscious had been working quietly in the background. This hints at layers of cognition operating below conscious awareness, blending deterministic processing with something more elusive, perhaps even chaotic or quantum influences. Neuroscience hasn't settled the free will debate, but it has reframed it. Instead of asking whether we're prisoners of determinism, we might ask how consciousness navigates the constraints of biology. Are we passengers on a train, or are we the engineers subtly shifting tracks laid down by our own brains? The answer could lie somewhere in between, a dance of determinism and emergence that makes us neither puppets nor gods, but something far more intriguing. Einstein's theory of relativity didn't just redefine gravity, it shattered our everyday notions of time. Picture the universe not as a series of fleeting moments, but as a vast, unchanging block where past, present, and future all exist simultaneously, like frames in a film strip frozen forever. This block universe view, known as eternalism, suggests that time is just another dimension, as real and unyielding as space. Your birth, your first heartbreak, even the moment of your death, they're all already out there, fixed in the cosmic fabric. From this perspective, the future isn't something that unfolds. It's a destination waiting to be discovered, as predetermined as the past. But here's where relativity throws a curveball. While the block universe seems like a slam dunk for determinism, Einstein's own theory introduces a strange flexibility. Time isn't absolute. It stretches and warps depending on how fast you're moving or how close you are to a massive object. Two observers can disagree on the order of events if they're in different reference frames. This relativity of simultaneity means there's no universal now stitching the cosmos together. So if the present is up for debate, how fixed can the future really be? Some physicists argue this flexibility cracks open a door for free will. If there's no objective present moment, perhaps the future isn't set in stone but exists in a state of potential, shaped by the choices made within each frame of reference. Others counter that the block universe is still fundamentally deterministic. Just because different observers see events in different orders doesn't mean those events aren't pre-written. It's like reading a book. You might skip ahead to the last chapter, but the ending was already printed. The debate gets even thornier when quantum mechanics enters the mix. Quantum events, with their inherent randomness, don't play nice with the tidy determinism of the block universe. If a particle's decay is genuinely unpredictable, how can its future state be already there in spacetime? Some theories, like quantum retrocausality, suggest that future events might even influence the past, twisting the block into something more fluid, a cosmic Möbius strip where cause and effect loop back on themselves. What's at stake here isn't just physics, it's the nature of reality itself. If eternalism is true, then every moment of joy, every tragedy, every choice you'll ever make is etched into the universe like grooves in a record. But if relativity's flexibility or quantum uncertainty undermines that, then perhaps time is more like a river, branching and bending in ways we can't yet map. Einstein might have envisioned a universe without dice, but the deeper we probe, the more it seems the cosmos is playing a game we're only beginning to understand. If the universe is just a vast equation, a cosmic spreadsheet where every possible outcome already exists, then determinism might not just be true, it could be unavoidable. That's the bold claim at the heart of Max Tegmark's mathematical universe hypothesis. Imagine reality not as a collection of atoms or energy, but as pure mathematical structure. Every galaxy, every thought, every fleeting emotion would just be a specific arrangement of numbers, a solution to some grand, underlying equation. In this view, the universe isn't just described by math, it is math, and everything that could ever exist within its rules already does. At first glance, this sounds like the ultimate deterministic nightmare. If all outcomes are baked into the equations, where's the room for choice or chance? But Tegmark's idea takes a surprising turn. Instead of a single, predetermined timeline, his framework suggests a multiverse, a sprawling landscape of mathematical possibilities where every variation plays out. Think of it like a calculator displaying every possible answer at once. In one slice of this reality, you're watching this video. In another, you clicked away. Both versions are equally real, just different solutions to the same cosmic formula. This blurs the line between math and metaphysics in ways that make even physicists pause. On one hand, the hypothesis offers eerie elegance. After all, math has an uncanny knack for predicting reality, from the orbits of planets to the behavior of quantum particles. If the universe is fundamentally mathematical, it would explain why equations like Einstein's E equals mc squared capture truths about energy and matter so perfectly. But on the other hand, it raises dizzying questions. If math creates reality, does that mean numbers and shapes exist independently, waiting to be discovered? Was Pythagoras right all along? Is God a mathematician? Critics push back, arguing that Tegmark's idea veers into philosophy. Just because the universe follows mathematical laws doesn't mean it is math. A blueprint isn't the same as a building. Others worry about testability. How do you prove that reality is purely mathematical when any experiment would itself be part of the system? Yet supporters counter that the hypothesis makes tangible predictions. If true, certain mathematical structures should correspond to observable features of our universe, like the precise values of fundamental constants. Finding these patterns could hint at deeper layers of mathematical reality. What makes this more than just abstract theorizing is its implications for determinism. If every possible universe exists, then causality splinters into infinite branches. Your choices still matter, they just manifest differently in each version of reality. It's not that the dice of the universe are loaded, it's that every roll happens somewhere. This doesn't erase free will so much as fractalize it, spreading agency across countless parallel narratives. The mathematical universe hypothesis doesn't settle the debate, it explodes it. Whether you see it as the pinnacle of determinism or its undoing depends on how you frame the question. Is math the rigid scaffolding of reality or the canvas for infinite possibilities? The answer might lie not in physics or philosophy alone, but in the strange, beautiful space where numbers and existence collide. String theory dangles the ultimate prize in physics, a single framework that stitches together the quantum and cosmic realms, a so-called theory of everything. At its heart lies a mesmerizing idea. The fundamental building blocks of reality aren't particles but tiny, vibrating strings, each oscillation producing the different forces and particles we observe. If proven, this could be the key to unlocking a perfectly deterministic universe, where every quirk of quantum mechanics and every curve of spacetime emerges from elegant, unified mathematics. But there's a catch. The very mathematics that makes string theory so promising also spawns a labyrinth of possibilities 10 to the power of 500 possible configurations, known as vacuum states. That's a number so vast it dwarfs the atoms in the observable universe. This landscape problem throws a wrench into the dream of determinism. If string theory allows for a near-infinite array of potential universes, each with its own laws of physics, how can we ever predict which one we're actually in? Imagine walking into a library where every book is written in a different language with no index or guide. You might suspect there's a unifying logic behind the shelves, but without a way to pinpoint the right volume, the theory feels more like a cosmic puzzle than a key. Some physicists, like Leonard Susskind, argue this isn't a bug but a feature, a reflection of nature's creativity, where multiple universes coexist in a vast multiverse. Others, like Roger Penrose, see it as a fatal flaw, a sign that string theory has strayed from testable science into mathematical speculation. The stakes couldn't be higher. If string theory's landscape is real, determinism might not be dead, but it's certainly diluted. Our universe's particular laws, the charge of an electron, the strength of gravity, could just be a random roll of the dice in a grand cosmic casino. On the other hand, if hidden symmetries or deeper principles eventually trim this jungle of possibilities down to a single, inevitable structure, we might yet find the universe's blueprint. For now, the quest for unification remains a high-wire act, balancing between the tantalizing promise of order and the dizzying specter of infinite maybes. What makes this more than an academic quibble is the way it forces us to confront the limits of human knowledge. String theory's equations are breathtakingly beautiful, but beauty alone doesn't guarantee truth. Without experimental evidence, some way to probe those extra dimensions or detect the faint echoes of vibrating strings, the theory lingers in a twilight zone between inspiration and desperation. Perhaps future breakthroughs like quantum gravity experiments or observations of primordial gravitational waves will tilt the scales. Until then, string theory stands as both a monument to our ambition and a humbling reminder that the universe might not owe us an easy answer. The search for determinism, it seems, is far from over. It's just grown infinitely more complex. The Big Bang wasn't just a beginning, it was a cosmic seed containing the entire genetic code of the universe. Every galaxy, every planet, every heartbeat of life was theoretically encoded in those first, unimaginably hot, dense moments. But here's the puzzle. If those initial conditions were set with perfect precision, like a clock wound up and left to tick, does that mean everything since, every supernova, every dinosaur's extinction, even your decision to watch this video, was just the inevitable unspooling of that first instant? Or was there a wild card shuffled into the deck during the universe's explosive infancy? Enter cosmic inflation, the theory that the universe underwent a fleeting but unimaginably rapid expansion in the first fraction of a second. During this period, space itself stretched faster than light, smoothing out the cosmos like a baker rolling dough, but inflation wasn't perfectly even. Quantum fluctuations, tiny, random hiccups in energy, left faint fingerprints on the fabric of spacetime. These microscopic ripples eventually grew into the gravitational seeds for galaxies, stars, and everything we see today. The staggering implication: the largest structures in the cosmos might trace back to subatomic randomness, a cosmic lottery where the winning numbers were drawn by quantum chance. This throws determinism a curveball. If the universe's initial conditions were pristine, with no quantum noise, we might live in a perfectly predictable cosmos, a vast, sterile clockwork where every atom's path was preordained. But inflation's quantum fluctuations suggest that randomness isn't just a quirk of particle physics. It's woven into the universe's very foundations. Picture a painter whose brushstrokes are guided by both careful planning and unpredictable tremors in their hand. The result isn't chaos, but a masterpiece where order and spontaneity intertwine. Some physicists argue that even these quantum fluctuations might not be truly random, that hidden variables or deeper laws could govern them, preserving determinism behind the scenes. Others see inflation as the ultimate dice roll, a moment when the universe chose its path from a buffet of possibilities. The answer could lie in the faint afterglow of the Big Bang itself. By studying the cosmic microwave background, the oldest light in the universe, scientists hunt for patterns that might reveal whether inflation's fluctuations were truly random or the product of something more deterministic. What's at stake isn't just a technicality of cosmology. If the universe's birth contained even a whisper of randomness, it means the future isn't just a pre-written script, it's a story with room for surprise, creativity, and perhaps even free will. The alternative, a cosmic fate so rigid that every thought you'll ever have was etched into the fabric of reality before time began. The choice between these visions isn't just about physics, it's about what kind of universe we call home. Black holes are the ultimate cosmic wildcards, regions where gravity crushes matter into oblivion, bending the rules of physics until they snap. But here's the twist: these cosmic vacuum cleaners might not just swallow stars and light. They could be erasing something far more fundamental: information itself. In a deterministic universe where every event is supposed to leave a trace, this is like setting fire to the cosmic ledger. If black holes truly obliterate information, it's not just a quirk of astrophysics. It's a direct challenge to the idea that the universe operates like a flawless, predictable machine. The heart of this paradox beats in the work of Stephen Hawking. In the 1970s, he made a startling prediction: black holes aren't completely black. They emit radiation now called Hawking radiation, slowly leaking energy until they evaporate entirely. But here's the catch: if a black hole vanishes, what happens to all the information about the particles it swallowed? Quantum mechanics insists information can't be destroyed. It might get scrambled, but it should always be recoverable in principle. Yet Hawking's calculations suggested otherwise. The radiation he envisioned was thermal, random, carrying no fingerprints of the original material. It was as if the universe had a shredder and black holes were feeding it secrets. This information paradox sent shockwaves through physics. If Hawking was right, determinism had a glaring loophole. The universe wouldn't just be unpredictable, it would be forgetful, losing bits of its own history like pages torn from a book. But not everyone was ready to accept that. Some theorists like Leonard Susskind fought back with the holographic principle, a radical idea that all the information falling into a black hole isn't lost. Instead, it gets encoded on the event horizon's surface, like a cosmic DVD where three-dimensional data is compressed into 2 dimensions. When the black hole evaporates, that information could theoretically be recovered from the radiation, preserving the universe's deterministic backbone. The debate gets even stranger when you consider quantum entanglement. Recent work on firewalls, hypothetical walls of energy at the event horizon, suggests that information might escape, but at a cost. Anything crossing the horizon could be vaporized in a blaze of quantum fury, creating a paradox where an astronaut falling in would both be incinerated and survive untouched, depending on whose math you trust. It's a mess that makes philosophers groan and physicists scribble faster. So where does this leave determinism? If information is preserved, even in some scrambled holographic form, the universe might still be a closed book, its pages intact. But if it's truly lost, we're left with a cosmos that forgets, a universe where the past isn't just hard to predict, but fundamentally unknowable. The answer could redefine not just black holes, but reality itself. After all, if the darkest objects in the cosmos can rewrite the rules, what else might we be missing? The multiverse isn't just a sci-fi trope, it's a serious scientific hypothesis that could rewrite our understanding of determinism. Picture a cosmic library where every book tells a different version of reality, each with its own unique set of physical laws. In one universe, gravity might be so weak that stars never form. In another, the speed of light is a crawl, and time stretches like taffy. If this sprawling landscape of parallel worlds exists, it raises a dizzying question. Does determinism hold firm across every branch of the multiverse, or does the sheer variety of these realms introduce an element of ultimate chance? Some versions of the multiverse, like those in eternal inflation theory, suggest a kind of meta-determinism. Every possible universe blooms into existence, but within each one, the laws of physics play out with unwavering precision. Think of it like a factory producing countless clocks, each ticks predictably, even if they all tell different times. In this view, determinism isn't broken. It's just multiplied, with every possible outcome unfolding somewhere in the cosmic ensemble. But other multiverse models flirt with chaos. Take the many worlds interpretation of quantum mechanics, where every quantum decision spawns a new universe. Here, the multiverse isn't a static collection of predetermined worlds, it's a frothing ocean of branching timelines, splitting endlessly with every particle's whim. There's no guiding hand, no master equation dictating which branches form. Instead, randomness reigns at the fundamental level, with each new universe carving its own path through the chaos. Then there's the elephant in the room. If the multiverse is real, could we ever test it? Some theorists look for clues in the cosmic microwave background, hunting for faint bruises left by collisions with other universes. Others propose that the precise values of fundamental constants like the strength of gravity or the mass of an electron might hint at a broader landscape of possibilities. But until we find hard evidence, the multiverse remains a tantalizing maybe, a canvas where determinism and chance paint in strokes too broad for our current science to trace. What makes this more than a thought experiment is the way it forces us to confront the limits of human knowledge. If the multiverse is real, our universe's laws might just be a local ordinance, not the cosmic constitution. Determinism could be a small-town rule in an infinite metropolis of possibilities, or it might not apply at all. The answer, if we ever find it, won't just settle a physics debate. It'll redefine what we mean by destiny itself. What if the universe isn't just governed by physics? What if it's running on code? The simulation hypothesis, once the stuff of late-night dorm room debates, has evolved into a serious scientific discussion. At its core is a mind-bending possibility. Our reality might be an artificial construct, a vast digital simulation created by some advanced civilization. If that's true, then determinism takes on a whole new meaning. Instead of asking whether the universe is predestined by physical laws, we'd be asking whether it's bound by the rules written into its programming. Think of it like a video game. In a perfectly deterministic simulation, every event from the collision of galaxies to the firing of neurons in your brain would unfold according to the algorithm's instructions. There'd be no wiggle room, no unscripted moments, but here's where it gets interesting. Even the most meticulously coded games sometimes glitch. Particles clip through walls, textures flicker, and NPCs behave unpredictably. Could quantum randomness, those dice rolls at the heart of reality, just be the cosmic equivalent of algorithmic noise, a byproduct of the simulation's processing limits, like a computer struggling to render every pixel perfectly? Not everyone buys this glitch theory. Some argue that a simulated universe would still need genuine indeterminacy to feel real to its inhabitants. After all, if every outcome were precalculated, wouldn't the illusion of free will crumble under scrutiny? Imagine playing an open-world game where every choice you make was already programmed, your characters, decisions just triggering preset scripts. That's the nightmare scenario for determinism in a simulation. We're not just players following rules, we're characters with no agency at all. Philosopher Nick Bostrom takes it a step further. His famous trilemma posits that at least one of these must be true. Either civilizations never reach the technological capacity to create simulations, they choose not to run them, or we're almost certainly living in one. If the third option holds, then determinism hinges on the simulator's goals. Did they build this universe to unfold like clockwork, or did they code in true randomness to keep things interesting? The answer could redefine not just causality, but the nature of existence itself. This isn't just speculative fun. Some physicists are actively looking for proof. If the universe is a simulation, it might have detectable resolution limits, tiny pixels of space-time that reveal themselves in high-energy particle experiments. Others hunt for mathematical patterns in cosmic constants, like finding repeating code in the universe's source files. So far, no smoking gun, but the search forces us to confront an eerie possibility. The laws we think govern reality might just be someone else's programming choices. The simulation hypothesis doesn't just challenge determinism, it reframes the entire debate. Are the dice of quantum mechanics rolling freely, or are they loaded by lines of code we can't see? Is the universe a flawless simulation running on cosmic servers, or a glitchy beta test with room for surprise? Either way, one thing's certain: the question isn't just whether we live in a matrix. It's whether the matrix has a script, and if we're all just reading from it. If every action is just a link in an unbreakable chain of cause and effect, then the foundations of morality start to tremble. Picture a courtroom where the defendant's crime, whether theft or violence, wasn't a choice but the inevitable result of genetics, upbringing, and the laws of physics. The gavel falls, but the question lingers: how can society punish or reward what was never truly free? This dilemma has haunted thinkers for millennia. The ancient Stoics saw determinism as liberation. arguing that accepting fate, whether predetermined or not, was the path to peace. To them, moral responsibility wasn't about controlling outcomes but aligning one's will with the universe's rhythm. A thief might be destined to steal, but the judge is equally destined to condemn, and both acts carry meaning within the cosmic order. Centuries later, existentialists like Jean-Paul Sartre flipped the script. Even in a deterministic universe, they argued, we're condemned to act as if we're free. Denying responsibility, Sartre claimed, is bad faith, a refusal to confront the weight of our existence. Imagine a chess game where the pieces believe they're choosing their moves. The board's rules might constrain them, but the game still demands engagement. In this view, determinism doesn't erase morality, it redefines it. Praise and blame aren't about ultimate freedom, but about the roles we play in life's unfolding drama. Yet not all philosophers could stomach this compromise. Hard determinists like Baron de Holbach dismissed free will as an illusion, insisting that holding people morally accountable was as absurd as blaming a hurricane for destruction. If our brains are just meat computers processing inputs, then justice becomes pure pragmatism. Punishment isn't about desert but deterrence, like training a dog with treats and shocks. This utilitarian approach reshapes prisons and laws into behavior modification systems, stripping away notions of sin or virtue. But here's the counterpoint. What if determinism and morality aren't mutually exclusive? Compatibilists like Daniel Dennett suggest that even in a clockwork universe, certain causes like rational deliberation can still ground responsibility. Think of a river flowing downhill. Gravity determines its path, but the water still responds to rocks and bends, carving a unique course. Similarly, our choices might emerge from prior causes, but when those causes include reasoning, empathy, and self-reflection, we're not just puppets, we're participants in shaping the chain. The stakes here aren't just theoretical. Legal systems worldwide wrestle with these questions. When a murderer's defense cites a genetic predisposition or childhood trauma, jurors face the uncomfortable truth. Under different circumstances, they might have stood in the defendant's shoes. Neuroscience complicates it further. Brain scans revealing damaged frontal lobes or abnormal activity challenge notions of blame. Should society lock away a malfunctioning brain or treat it? The answer hinges on whether we see humans as agents or artifacts. And then there's the existential weight. If determinism is true, does life lose its meaning? Albert Camus thought not. In his myth of Sisyphus, doomed to eternally push a boulder uphill, he found absurd heroism. The rock will always roll back, but the act of pushing, of choosing to engage, creates purpose. Determinism might erase ultimate control, but not the urgency of living. After all, even if this moment was destined, it's still your moment, trembling with all the joy, pain, and mystery that makes existence indelible. The debate isn't about settling the score between fate and freedom. It's about how we navigate a universe that might not care about our choices, yet demands we make them anyway. Whether you side with the Stoics, the existentialists, or somewhere in between, one truth remains. The question of determinism doesn't just shape how we understand the cosmos. It shapes how we understand ourselves. Religious and spiritual traditions have grappled with the tension between fate and free will for centuries, offering perspectives that both clash and converge with scientific determinism. In Christianity, the doctrine of predestination, championed by figures like John Calvin, asserts that God has already determined who will attain salvation, a view that mirrors the unbroken chain of cause and effect in a deterministic universe. Yet other branches of Christianity, like those rooted in free will theism, argue that human choices genuinely shape destiny, creating space for moral responsibility. Islam presents a similar duality. The concept of qadar, or divine decree, suggests that all events are preordained by Allah, while humans still face accountability for their actions. It's as if the universe is a book written in advance, yet we're tasked with reading each page as though it could turn differently. Eastern philosophies introduce their own nuances. Hinduism's karma weaves determinism and agency together. Every action generates consequences that shape future rebirths, creating a cosmic balance where past deeds influence present choices. But here's the twist. The Bhagavad Gita teaches that while actions are bound by cause and effect, detachment from outcomes offers a kind of spiritual freedom. Buddhism, meanwhile, rejects rigid determinism, emphasizing the fluidity of dependent origination, the idea that all phenomena arise from interconnected causes, but not in a linear, unchangeable way. Imagine a net of jewels where each reflects the others. Tug one thread and the whole web shifts. This isn't fate so much as a dynamic dance of conditions. The dialogue between faith and physics becomes even richer when science enters the conversation. Some theologians argue that quantum randomness might be the mechanism through which divine will operates, a way for God to influence the world without violating natural laws. Others see determinism and predestination as fundamentally different. Science describes how the universe unfolds, while religion addresses why. Think of it like a novelist and a physicist analyzing a falling apple. One interprets its symbolism, the other its acceleration. Yet irreconcilable differences remain. For scientists, determinism is a hypothesis tested by equations and experiments. For many believers, predestination is a matter of divine mystery beyond human scrutiny. The irony, both worldviews grapple with the same existential itch, the longing to know whether our lives are scripted or spontaneous. Perhaps the most profound insight lies not in choosing sides, but in recognizing how both traditions, in their own ways, confront the awe and unease of a universe that might be far less random, or far more, than we dare to believe. Artificial intelligence presents a fascinating paradox in the debate over determinism. On the surface, AI systems are the ultimate clockwork creations. Every line of code, every neural connection follows precise mathematical rules. Feed an algorithm the same input 1,000 times, and it will produce identical outputs like a flawless cosmic calculator. There's no ghost in this machine, no spontaneous rebellion against its programming. Yet anyone who's watched a large language model generate eerily human-like text or seen a robot adapt to an unforeseen obstacle knows these systems can feel uncannily alive. How do we square this circle, the tension between rigid code and emergent creativity? Take deep learning networks. Their behavior isn't explicitly programmed but emerges from trillions of weighted connections trained on mountains of data. When AlphaGo made its legendary move 37 against Lee Sedol, a play so unconventional it stunned human experts, it wasn't following a script. The move emerged from patterns so complex even its creators couldn't fully trace the logic. This mirrors the human brain's own mysteries, where simple neurons give rise to consciousness through connections we're still deciphering. Does that make AI any less deterministic? Not technically. Every calculation is still governed by physics and math, but when complexity reaches a certain threshold, predictability starts to blur. Philosophers like Daniel Dennett see this as a clue to our own free will. If sophisticated enough, even deterministic systems can exhibit what he calls evitability, the ability to navigate choices in ways that feel authentically volitional. Picture a chess engine evaluating millions of possible moves before selecting one. The outcome is mathematically determined, but the path feels intentional. Could human decision-making be a biological version of this process? our brains might weigh options through layered neural computations, creating the illusion of choice from underlying physical laws. Yet there's a crucial difference. Current AI lacks qualia, the raw, subjective experience of being. A self-driving car doesn't want to avoid collisions. It executes risk calculations. This absence of inner life keeps AI firmly in the deterministic camp for many thinkers. But what if future artificial general intelligence develops something akin to consciousness? Would its decisions then carry moral weight? The question forces us to confront whether free will requires true randomness or simply sufficient complexity to make predictability functionally irrelevant. The rise of AI doesn't just challenge how we build machines, it holds up a mirror to our own minds. If deterministic algorithms can mimic creativity, adaptability, even strategic intuition, perhaps human free will isn't about breaking causality, but riding its waves with such sophistication that the ride feels like freedom. The deeper we peer into silicon minds, the more we're forced to ask, is the magic of choice in the machinery or the mystery we project onto it? Biological evolution presents a tantalizing puzzle at the intersection of determinism and chaos. On one hand, the engine of life's diversity genetic mutation appears utterly random. A cosmic ray strikes a strand of DNA, a copying error slips past repair enzymes, and suddenly a new trait emerges, unplanned and unpredictable. Yet step back and patterns emerge. The repeated evolution of similar traits, like camera-like eyes in both octopuses and humans, hints at something deeper, as if life is navigating a hidden maze where certain outcomes are inevitable. This raises a provocative question. Is evolution truly a game of chance, or are there invisible rules nudging life toward predictable forms? Consider the humble lens protein crystallin, essential for focusing light in animal eyes. It didn't evolve just once, but independently in jellyfish, vertebrates, and cephalopods. Such convergent evolution suggests that physics and chemistry might constrain life's possibilities, funneling organisms toward optimal solutions. It's like pouring water onto uneven ground. The droplets take different paths, but gravity ensures they all pool in the same low spots. Biologist Simon Conway Morris argues that these repeating motifs point to a kind of biological determinism, where life's tape, if rewound and replayed, would converge on similar design. But randomness still reigns at the molecular level. Mutations arise from quantum-scale accidents, a proton tunneling here, a molecule vibrating there, events so small they flirt with Heisenberg's uncertainty principle. In this light, evolution is a dance between chaos and necessity. Random mutations provide the raw material, but natural selection acts as a filter, preserving only what works. The result, a process that feels purposeful but is built on a foundation of chance. Some theorists push further, proposing that evolution might harness quantum effects to accelerate adaptation. Photosynthesis, for instance, uses quantum coherence to optimize energy transfer in plants. Could similar tricks influence genetic mutations, subtly biasing them toward useful outcomes? It's a controversial idea, but if true, it would blur the line between accident and orchestration. The debate isn't just academic. If evolution carries hidden order, it changes how we search for life beyond Earth. Convergent traits suggest that alien biospheres might resemble ours: eyes, wings, even intelligence could be universal solutions to survival's challenges. But if randomness dominates, the cosmos could teem with forms beyond our imagination. Either way, life's story isn't just about genes and ecosystems. It's a test case for determinism itself, a billion-year experiment probing whether the universe plays dice with biology or deals from a stacked deck. Time travel isn't just a sci-fi fantasy, it's a thought experiment that stretches determinism to its breaking point. Imagine stepping into a time machine, traveling back to the past, and accidentally preventing your own birth. The infamous grandfather paradox isn't just a plot hole waiting to happen. It's a direct challenge to the idea of a universe bound by unbreakable cause and effect. If you could alter the past, determinism crumbles like a house of cards. But here's the twist. Some physicists argue the universe might have built-in safeguards, bending reality to prevent paradoxes before they happen. Consider the Novikov self-consistency principle, proposed by Russian physicist Igor Novikov. His theory suggests that any actions taken by a time traveler were already part of history, creating a closed loop where events self-correct to avoid contradictions. Think of it like a screenplay where every edit you make was always part of the script. If you travel back to save a famous scientist from an untimely death, only to discover they never actually died in the first place, your attempt to change history becomes the very reason history unfolded as it did. The universe, in this view, isn't just deterministic, it's self-censoring, ironing out inconsistencies before they can unravel causality. Then there's the mind-bending concept of parallel timelines, where every time-traveling intervention spawns a new branch of reality. In this multiverse model, you could indeed prevent your own birth, just not in the original timeline. Your actions would create an alternate universe where you never existed, leaving the first version of history untouched. This sidesteps paradoxes entirely, but at a cost. Determinism becomes local, confined to individual timelines rather than the cosmos as a whole. It's like a tree splitting into infinite branches, each one following its own deterministic path, even as the trunk fractures into possibility. Quantum mechanics adds another layer of strangeness. Particles like electrons don't just move through time in one direction. Some interpretations suggest they can loop back, creating feedback cycles where cause and effect blur. Experiments with quantum particles even hint at retrocausality, where future events might influence the past. If true, time itself could be more like a tangled web than a straight line, with determinism weaving through it in ways we're only beginning to imagine. The debate isn't just theoretical. Wormholes predicted by Einstein's equations could in principle create shortcuts through spacetime. While no one's found a stable, traversable wormhole yet, their hypothetical existence forces us to confront whether the universe would allow time travel without breaking its own rules. Would physics enforce a cosmic censorship, ensuring only self-consistent journeys are possible? Or would the fabric of reality fray at the edges, revealing cracks in determinism itself? Time travel might still be the stuff of speculation, but the questions it raises are eerily practical. If the future is already written, are we flipping through pages or scribbling in the margins? The answer could redefine not just how we see time, but how we see ourselves passengers on a one-way ride, or co-pilots in a universe still writing its own story. Consciousness might be the ultimate wrench in the gears of determinism, an enigmatic force that resists reduction to mere physics and chemistry. While atoms and neurons follow predictable laws, the raw experience of being you, the taste of coffee, the sting of regret, the sudden flash of insight feels irreducible to equations. This isn't just philosophical hand-waving. Theories like panpsychism propose that consciousness isn't an emergent property of complex brains, but a fundamental feature of the universe itself, as intrinsic as gravity or electromagnetism. If true, it would mean even elementary particles harbor some rudimentary form of experience, and the cosmos isn't just a cold, deterministic machine. It's a vast, shimmering network of subjective awareness. Consider the humble electron. In classical physics, it's just a speck of charge obeying deterministic laws. But what if it also carries a flicker of inner life, however faint? Panpsychists argue that consciousness could scale from the simplest particles to the rich inner worlds of humans, like pixels forming an image. This isn't about electrons thinking, it's about the raw potential for experience being woven into the fabric of reality. If mind is as basic as matter, then determinism faces a radical challenge. How can physics fully account for a universe where subjectivity is baked into every quark and photon? Then there's the hard problem of consciousness, coined by philosopher David Chalmers. Even if we map every neural pathway in the brain, he argues, we're left with an unbridgeable gap. Why should all that electrical activity feel like anything at all? A robot could mimic pain responses without ever experiencing agony. This gap suggests consciousness might be more than the sum of its physical parts, a wild card that slips through determinism's net. Some theorists like Stuart Hameroff and Roger Penrose go further, proposing that quantum processes in microtubules within brain cells could generate non-computable decisions, injecting genuine unpredictability into cognition. The implications ripple far beyond theory. If consciousness introduces elements that defy physical determinism, it could reshape how we understand free will. Not the magical, unconstrained kind, but a version where our choices emerge from layers of experience irreducible to pure causality. Think of a jazz improvisation. The notes follow musical rules, but the expression transcends them. Similarly, even in a universe governed by physical laws, consciousness might compose melodies of meaning that physics alone can't notate, yet critics push back. Neuroscience shows how tightly our decisions correlate with brain activity, damage a specific region, and personality transforms. If consciousness were truly independent of physics, how could a physical injury alter it so profoundly? This tension between the visceral reality of subjective experience and the brute force of neural mechanisms keeps the debate alive. Whether consciousness is a ghost in the machine or the machine itself remains one of science's deepest mysteries, and the answer could redefine not just determinism, but what it means to be alive in the cosmos. Quantum mechanics doesn't just rewrite the rules of physics, it might hold the key to unlocking the mystery of consciousness itself. At the tiny junctions between brain cells, where electrical impulses become thoughts, some scientists suspect quantum phenomena could be at work. The idea isn't as far-fetched as it sounds. Photosynthesis, a process vital to life on Earth, relies on quantum coherence to achieve near-perfect energy transfer in plants. If nature harnesses quantum effects for something as fundamental as turning sunlight into food, why couldn't the brain exploit similar tricks to generate consciousness and perhaps even free will? This radical proposition comes from physicists like Roger Penrose and anesthesiologist Stuart Hameroff. Their orchestrated objective reduction theory suggests that microtubules, tiny protein structures inside neurons, act as quantum processors. In this view, consciousness arises from quantum vibrations in these microtubules, collapsing wave functions in a way that introduces genuine unpredictability into decision-making. It's not just about neurons firing in predictable patterns. It's about quantum uncertainties percolating up to influence our choices. Imagine rolling a die where the outcome isn't just unknown but fundamentally undetermined until the moment you look. That flicker of quantum randomness, amplified by the brain's complexity, could create the illusion or reality of free will. Skeptics aren't convinced. Neuroscientists like Patricia Churchland argue that invoking quantum mechanics to explain consciousness is a Hail Mary pass, an attempt to solve one mystery by appealing to another. Even if quantum effects operate in the brain, they point out, randomness at the subatomic level doesn't equate to free will. A decision dictated by quantum fluctuations is no more free than one dictated by classical physics. It's just harder to predict. Philosopher Daniel Dennett compares it to replacing a deterministic puppet master with a capricious one. The strings might be invisible, but you're still being pulled. Then there's the practical hurdle. The brain is warm, wet, and noisy, a hostile environment for delicate quantum states. Most quantum effects we observe occur in carefully controlled labs, chilled to near absolute zero. Critics argue that in the bustling, body temperature chaos of the brain, any quantum coherence would decohere almost instantly, like a sandcastle crumbling in a tidal wave. Yet proponents counter with examples like the European robin, which navigates using a quantum compass in its eye, proof that biology can sustain quantum effects even in messy, real-world conditions. The debate isn't just academic. If quantum consciousness theories hold water, they could bridge the gap between determinism and the palpable sense of agency we all experience. Rather than a universe of unbreakable cause and effect chains, we'd live in one where consciousness introduces a subtle indeterminacy, not quite freedom from physical laws, but freedom within their cracks. On the other hand, if critics are right, the search for free will might need to look beyond quantum woo toward the emergent properties of complex systems. Either way, the collision of quantum physics and neuroscience forces us to confront a haunting possibility. The mind might not be a mere passenger in a deterministic universe, but a participant in its unfolding. If every choice we make is preordained by the laws of physics, where does that leave right and wrong? The courtroom becomes a stage where actors perform lines written billions of years ago, yet we still judge their performances as if they had a say in the script. This paradox cuts to the heart of ethical determinism, a philosophical minefield where moral responsibility collides with the unyielding chain of cause and effect. Consider the case of a murderer whose violent impulses stem from a childhood of abuse compounded by a genetic predisposition. The legal system treats them as a culpable agent, but if their actions were inevitable given their biology and environment, is punishment justice or just another domino falling? Philosophers have wrestled with this dilemma for centuries. Hard determinists like Paul Henry Theory argue that moral judgments are fundamentally incoherent in a clockwork universe. If no one could have acted otherwise, blame becomes theater, a societal reflex with no grounding in reality. Yet others, like compatibilists, carve out a middle path. They redefine free will not as freedom from causation, but as freedom from coercion. A person acting according to their desires, even if those desires were shaped by prior causes, can still be morally accountable. Think of a river flowing downhill. Gravity determines its path, but the water still responds authentically to the landscape. The implications ripple through legal systems worldwide. Norway's rehabilitative prison model, which treats criminals as broken systems to repair rather than villains to punish, reflects a more deterministic worldview. Contrast this with retributive justice systems that demand an eye for an eye, clinging to the illusion of ultimate moral agency. Neuroscience further complicates the picture. Brain scans revealing tumors or abnormalities in defendants have led to reduced sentences, tacitly acknowledging that biology can override what we call choice. But here's the counterintuitive twist. Even if determinism undermines traditional notions of blame, it might deepen our empathy. Recognizing that every bully, every hero, and every bystander is shaped by forces beyond their control could foster a society focused on prevention rather than punishment. Imagine a world where we design cities to reduce crime triggers instead of filling prisons, where education systems adapt to neurological diversity rather than labeling kids as good or bad. Determinism doesn't have to erase ethics, it could rewrite them as tools for steering the inevitable toward kinder outcomes. The debate isn't just about abstract philosophy, it's about the stories we tell ourselves to maintain social order. Whether we cling to free will or surrender to determinism, the real test is how these beliefs shape our capacity for compassion and our vision of justice. After all, even in a predetermined universe, the act of questioning these very ideas might be the most ethical domino of all. Technological determinism whispers a seductive idea into the ear of progress, that every invention, from the wheel to the algorithm, was always meant to be. Like a river carving its canyon, technology's path seems inevitable. Steam engines birthing factories, smartphones rewiring society, AI looming as the next unmissable milestone. But peel back the surface and a more tangled story emerges. Behind every inevitable breakthrough are forks in the road where culture, politics, and sheer human stubbornness redirected the current. Take the QWERTY keyboard, designed to slow typists down to prevent jammed mechanical keys. It's still here not because it's optimal, but because momentum and infrastructure locked us into a suboptimal design. In that sense, technology isn't a force of nature, it's a hall of mirrors reflecting our choices, accidents, and power struggles. History brims with roads not taken. In 19th century Britain, clean pneumatic tubes once rivaled steam engines for transporting goods. Imagine cities humming with air-powered deliveries instead of choked by exhaust. The system failed not because of physics, but logistics and lobbying. Similarly, Japan's Betamax videotapes famously lost to VHS despite superior quality, casualties of corporate alliances and consumer habits. These aren't footnotes, they're proof that what feels like technological destiny is often just the residue of who held the most influence when the dice rolled. Even the internet, that seeming inevitability, could have been otherwise. Early digital networks like France's Minitel offered walled garden online services decades before the web. Had their model prevailed, we might navigate a splintered digital landscape instead of today's interconnected one. Yet determinism creeps back in through the back door. Once a technology reaches critical mass electric grids, smartphones, social media, it reshapes society so profoundly that reversing course becomes unthinkable. We call this path dependence, where early choices funnel us into futures that feel predestined. Try imagining a world without GPS. The satellites overhead seem like necessities now, but their military origins remind us they were born from Cold War strategy, not some innate human need for turn-by-turn navigation. This feedback loop between tech and society creates a paradox. While no single innovation is fated, the collective weight of our adaptations makes the trajectory feel unstoppable. The rise of artificial intelligence sharpens this tension. Tech giants insist AI is an unavoidable frontier, as natural as fire or electricity. But scratch the surface and you'll find competing visions, from open-source collectives to corporate monopolies, each fighting to define what inevitable looks like. When OpenAI's ChatGPT exploded into public consciousness, it wasn't because the technology magically matured. It was because investors bet billions, engineers tweaked algorithms for viral engagement, and society grew hungry for a new digital oracle. None of this was pre-written in the stars. Perhaps the truth lies in recognizing two kinds of determinism at war. Physical determinism deals with unbreakable laws like gravity or thermodynamics, while technological determinism is a sleight of hand, a story we tell to justify the world we've built. The microchip wasn't destiny, but once it existed, it made certain futures far more probable. In that gap between possibility and probability, human agency still breathes. We might not control where the river of progress flows, but we can, if we choose, redraw its banks. Long before Laplace's demon or quantum dice, humans grappled with fate through myth and metaphor. The ancient Greeks envisioned the Moirai, three sisters who spun, measured, and cut the thread of each life, weaving destiny into an unbreakable tapestry. Norse legends spoke of the Norns carving runes into the trunk of Yggdrasil, the world tree, their inscriptions dictating the rise and fall of kings. These weren't just stories, they were attempts to reconcile the terrifying idea that our lives might be scripts written by invisible hands. What's striking isn't just how widespread these narratives are, but how they oscillate between resignation and rebellion. In the Mahabharata, the warrior Arjuna is crushed by the weight of predetermined duty until Krishna reframes it as sacred purpose. Meanwhile, Oedipus flees a prophecy only to sprint headlong into its fulfillment, his struggle against fate making its grip seem all the tighter. Fast forward to modern fatalism, and the echoes are unmistakable. In the American South, blues musicians sang of being born under a bad sign, their lyrics steeped in the ache of inevitability. Japanese Shikota ga Nai, It Cannot Be Helped, captures a cultural embrace of life's unchangeable currents. Yet contrast this with the relentless optimism of Silicon Valley's "You can code your destiny" mantra, where algorithms promise to hack life's variables. These aren't just philosophical differences, they're survival strategies. When hurricanes or droughts strike, communities leaning into fatalism often recover with less psychological trauma than those conditioned to believe every disaster is a solvable puzzle. Determinism, it seems, wears many masks, sometimes a comfort, other times a cage. But here's where culture throws a wrench into the determinism debate. In traditions like Yoruba spirituality, fate isn't a fixed endpoint but a negotiation. Before birth, you choose a life path with the deity Orunmila, yet through divination and sacrifice, you can soften its sharper edges. This middle path, what scholars call soft determinism, mirrors modern compatibilism, suggesting that even in a universe of causes, there's room to dance with the rhythm. Meanwhile, in Calvinist theology, predestination became a divine lottery. Your salvation or damnation was preordained, yet believers scrutinized every action for signs of grace, turning fatalism into fuel for moral rigor. The irony, both systems, ancient and modern, use the idea of inevitability to inspire action rather than passivity. The tension spills into pop culture. Films like The Matrix and Arrival pit characters against seemingly unchangeable futures, only to reveal that embracing determinism, knowing the script, can be the ultimate act of agency. When Louise Banks learns the alien language in Arrival and sees her future sorrow, she chooses it anyway, transforming predestination into a kind of bittersweet sovereignty. This narrative trope resonates because it mirrors our lived paradox. We plan vacations as if we're in control, then panic when flights get cancelled, swinging between architects and passengers of our lives. Perhaps the most revealing cultural lens is humor. From Groundhog Day to Rick and Morty, deterministic themes become fodder for laughter precisely because they expose our absurd dance with control. Phil Connor's endless loop of February 2nd starts as a prison, but his eventual acceptance unlocks growth, a metaphor for how confronting life's constraints can paradoxically set us free. Meanwhile, Rick Sanchez's nihilistic rants about everything being preordained mask a deeper terror. If nothing matters, then his genius is just a fluke of physics, not proof of superiority. What these stories share is a refusal to let determinism have the last word. Whether through myth, music, or memes, cultures keep rewriting the same question: are we prisoners of fate, or is the illusion of freedom itself a kind of liberation? The answer might lie not in choosing a side, but in recognizing that the question itself, the endless human struggle to wrestle meaning from the cosmic script, is what makes us more than just characters in a predetermined plot. The future of determinism hangs in a delicate balance, suspended between the cutting edge of quantum gravity and the uncharted frontiers of consciousness. Picture scientists at CERN probing the fabric of spacetime with particle colliders, while neuroscientists map the brain's labyrinthine networks, both searching for clues to the same existential riddle. Will these parallel quests eventually converge on a universe of unbreakable causality, or will they uncover layers of unpredictability deeper than we've dared to imagine? One of the most promising and perplexing avenues is the search for a theory of quantum gravity. General relativity paints a smooth, deterministic cosmos where spacetime curves predictably around massive objects. Quantum mechanics, by contrast, gives us a subatomic world buzzing with chance and uncertainty. Bridging these two frameworks could either reconcile determinism with quantum weirdness or reveal a fundamental randomness woven into the universe's very architecture. Loop quantum gravity, for instance, suggests spacetime might be granular, composed of tiny, indivisible units. If these atoms of space behave deterministically, the larger universe might still operate like clockwork. But if their interactions are inherently probabilistic, the bedrock of reality itself could be shakier than we thought. Then there's the enigma of consciousness. If the mind arises purely from deterministic neural processes, free will might indeed be an elaborate illusion. But what if consciousness taps into quantum phenomena, as some theorists propose? The Orch or hypothesis, for example, posits that quantum vibrations in microtubules, tiny structures within brain cells, could generate moments of genuine unpredictability, creating openings for non-algorithmic decision-making. Skeptics argue the brain is too warm and noisy for such delicate quantum states, but if evidence emerges that consciousness exploits quantum effects, it could rewrite the rules of agency. Cosmology, too, holds wild cards. The discovery of primordial gravitational waves, ripples from the universe's first moments, might reveal whether quantum fluctuations during inflation were truly random or followed hidden patterns. Some models of the multiverse suggest that every possible cosmic configuration exists somewhere, making our universe's laws seem less like inevitabilities and more like a roll of the dice. Even dark energy, the mysterious force accelerating the universe's expansion, could hold clues. If its strength varies unpredictably across spacetime, determinism might not just be incomplete, it could be fundamentally unworkable on cosmic scales. Amid these uncertainties, one thing is clear: the debate isn't just about physics, it's about the stories we tell ourselves. A deterministic universe offers the comfort of order, a cosmos where everything happens for a reason. An indeterminate one, though, leaves room for spontaneity, creativity, and perhaps even meaning that isn't pre-written. As we peer deeper into black holes, simulate quantum systems, and decode the brain's secrets, we're not just testing hypotheses, we're deciding what kind of reality we're willing to inhabit. The answer, when it comes, won't just settle a scientific dispute. It will redefine what it means to be human in a universe that's either a grand, unfolding equation or something far more mysterious. Staring into the night sky, it's easy to feel both insignificant and strangely connected, a speck of stardust pondering its own existence. That's the paradox determinism forces us to confront. If every atom in your body, every synapse firing in your brain, traces back to the Big Bang's initial conditions, where does that leave you? The answer isn't just in textbooks. It's in the quiet moments when you wonder whether your choices are truly yours or just ripples in a cosmic river flowing toward an inevitable sea. Some find solace in determinism's embrace. There's a peculiar freedom in accepting that life's twists aren't personal, that heartbreaks and triumphs were never truly up for grabs. The Stoics knew this well. They practiced amor fati, love of fate, not as resignation but as a way to align their will with the universe's rhythm. Imagine carrying that mindset into daily life. Setbacks become less about blame and more about navigation, like a sailor reading currents rather than raging against the storm. Yet others recoil at the thought. The idea that a childhood dream, a hard-fought victory, or even an act of cruelty was preordained can feel like theft, a robbery of meaning. But here's the twist. Whether the universe is deterministic or not, your experience of choice is real. The joy of creating art, the guilt of a harsh word, the pride of perseverance, these emotions don't vanish because physics might govern them. They're the colors on the canvas of your life, regardless of who mixed the paints. This tension between acceptance and rebellion isn't just philosophical, it's deeply human. Consider how we tell stories. Heroes defy fate in myths from Gilgamesh to the Matrix, yet we also cherish tales of destiny like Oedipus or Harry Potter. We're drawn to both narratives because they reflect our dual nature. Creatures who long for control but secretly wonder if there's a grand design. Even modern therapy echoes this dance. Cognitive behavioral techniques focus on changing thought patterns agency, while mindfulness teaches surrender to the present moment acceptance. Science, too, mirrors this duality. Neuroscientists trace decisions to brain activity milliseconds before consciousness kicks in. Yet psychologists celebrate neuroplasticity, the brain's ability to rewire itself through experience. One perspective suggests we're passengers, the other implies we're pilots tweaking the cockpit mid-flight. Maybe the truth isn't a binary but a spectrum, where determinism sets the boundaries but leaves room to wander within them. Ultimately, the question isn't just whether the universe is predetermined. It's how you choose or are compelled to live within it. Do you see yourself as a character in a pre-written epic, finding beauty in the prose, or as a co-author, scribbling in the margins despite the ink's dry? The answer might not lie in physics labs or philosophy texts, but in the quiet certainty that wondering itself, this act of questioning your place in the cosmos, is what makes you undeniably, irresistibly human. From Laplace's demon to quantum dice, the question of determinism stretches across centuries, threading through the fabric of science, philosophy, and the very way we see ourselves. The dream of a perfectly predictable universe where every event clicks into place like gears in a cosmic clock has haunted thinkers from Newton to Einstein. Yet as we peel back the layers of reality, we're met with quantum particles that defy prediction, chaotic systems that amplify the faintest whispers into storms, and the stubborn enigma of consciousness itself. Science may lean toward a universe humming with unpredictability at its core, but the allure of determinism lingers like a half-remembered melody, tempting us with the promise of order in the chaos. Perhaps the truth lies somewhere in the tension between these extremes. Consider the humble roll of dice. In a Newtonian world, with perfect knowledge of the throw's force, the air's resistance, and the table's texture, you could calculate the outcome with pinpoint accuracy. But introduce quantum uncertainty, the infinitesimal randomness at the atomic level, and even the most meticulous prediction unravels. The dice aren't just hard to predict, their tumble carries a whisper of genuine chance. Yet for all its randomness, the universe isn't lawless. Stars still burn, planets orbit, and apples fall, not because they must, but because probabilities stack so overwhelmingly in favor of certain outcomes that they might as well be certain. This dance between order and chaos mirrors our own lives. We plan careers, relationships, and dreams as if the future is ours to shape. only to collide with twists of fate, a chance encounter, an unexpected diagnosis, a global event that reshuffles the deck. Does determinism rob these moments of meaning, or does it deepen them? The Stoics found purpose in surrendering to fate's currents, while existentialists like Sartre insisted we must act as if we're free, even in a universe that may not permit it. The irony is palpable. Whether the cosmos is predetermined or not, our experience of wrestling with the question itself becomes part of the story. So where does that leave us? Maybe the answer isn't a binary deterministic or not, but a spectrum. A universe where causality reigns at macroscopic scales, but quantum quirks leave room for spontaneity. Where brains, forged by evolution's trial and error, generate minds that feel like authors even if they're participants. Or perhaps, as some theorists suggest, the very notion of determinism is a human projection, a way to impose narrative on a reality too vast and strange to fit into our frameworks. The beauty of this mystery isn't just in solving it, but in the act of questioning. Every experiment probing quantum foundations, every debate about free will, every late-night thought about destiny's grip, they're all part of a grand collective curiosity. Whether the universe is a locked puzzle or an open canvas, the search for answers reminds us how astonishing it is to be here at all, atoms arranged just so, pondering the forces that shaped us. So keep wondering, keep exploring, and drop your take below. Do you see the cosmos as a clockwork, a kaleidoscope, or something even wilder? The conversation, at least, is far